So in this session I will give you an introduction to forces. Forces are like the main player when it comes to movement of the particles and the magic. Invisible forces make everything move. So this will be an introduction and we can go straight into Blender now. And if you have downloaded my file, you should now have Intro Forcesingeneral, and it will look like this on your screen. What we have right now is particles and a UV sphere, but nothing happens when I run the animation. And that is because we need forces. Before adding them, I'll go through the setup for the particles. So go to the particle properties. Then you can see what I've done here. I have 500 particles, frame start and end is 1, so all particles are created in the first frame, and a long lifetime, since I don't want them to die during the animation. In source I use volume, so that is why I have particle inside, and we don't have any velocity, since I put 0 to normal, and the rotation I have, but it doesn't matter right now, looks nicer later on. And then we have the physics. That I put to Newtonian. And then the particles should normally fall down because of gravity, but they don't. And the reason that they don't is because I prevent these particles from using gravity. Not in the scene, however. The scene still has gravity, but in the particle settings I do this. So go to the particle settings again, and by scrolling down to something that we call field weights, there you can decide which type of force that should interact with your particles. So right now, as you can see, if we look here, we have gravity to 0 for my particles, and if I start animation after I put gravity to 1, you can see now that all the particles are falling down. This because I have activated gravity. If using 0, I prevent the gravity, but I still let all the other forces work here. So that is how it works. And as you can see now, all is set to 1, and that means that if I put in a new force now, it will interact as it should. Okay, I think we should add gravity now, but before we do that, we make room for forces in the collection tree. So create a new collection, select collection, and then select new, so you get a new collection. Then we should have collection 2, double click, select and write forces. So we know what it is. Now select the collection forces, press Shift A, select the force field, and then turbulence, because it will give some movement on the particles. Okay, so now it is in here, and we have a force in the collection forces, and now I press the animation. When I press the animation, you can see now that we have some movement on the particles. They move for infinity, because we don't have any boundaries on this force. Thus it will just continue to work all over the place. You can see how they are moving in a random pattern here in the scene. So they are slowly moving from the planet, and sooner or later we will have no particles near the planet at all, so that we have a force in action. Now I will go through the general parameters for force, so you know what type of setting you should have in there. Start by selecting a force, in our case field here, then go to physics property. And in the physics property, we have all the parameters for the force. The first thing to see is the type, and we are using turbulence. We can change that later on, and it's easy to change from one force to another force. And then we have shape. Shape is how force will react to the emitter shape. And now we have point, but it could also be line, a plane, or in some cases a curve. And there is also a few additional options. What you see in a list depends on the type of object that the force uses and the type of force. Then comes strength. Strength is the power of the particles. So if the amount is 1, we have this movement. Smooth particles are moving like slowly around. If I put it to 10 and then run the animation again, you can see that we have a lot more action. Everything is moving quickly away from this planet. So the power strength is depending also on the mass of the particles. That means a low mass don't need so much strength, but with a high mass you will need to have more strength to push those particles. And I can show you here by just changing the mass of the particles. So I select the UV sphere, then in my particle properties I go up a bit until I find a mass. And now I have 1 kilo, and I change it to 100 and run the animation. And now you can see it's not completely still, but very slow in movement. The strength of moving 100 kilos is too low with a value of 10. So the mass matters a lot. I'll change back to 1 kilo, and suddenly we have a lot of action compared to the calm movement of using 100 kilos. That is one thing that is vital to know when you're working with strength. That mass is one very important factor. That means that if you use scale randomness and check this multiply mass with size, you will get different amount of pushing and pulling from the force. Okay? So I think that let's go back to the force field and the parameters. So select the field and then select the physical properties so we can see them, and then go to frame 1. I will not go through size in this session, it's just for turbulence and not a general parameter. So instead let's take a look at flow instead, which is general. Flow is an effect that changes turbulence into like regular airflow, and you can easily see the difference. If I don't have any flow, the particles are living like their own life. This was a bit fast. I decreased the strength to 1 again. So as I said, they are living their own life, and no particle knows anything about another particle. So each particle selects its own path, and they are very individual. Now I change the flow to 2, and then I run the animation again, and now the particles will group together, and they also reveal the flow of the force in a more like visible pattern. So now you can see more clear how everything is following the force like this. You also see how the particles follows the same path and are grouped together, instead of selecting millions of different paths. So, with flow, you can do really interesting things. Now you know about flow. Then we have noise amount. Since turbulence is mostly noise, you will not see so much of a difference, so I'll select another type of force. And I think we should use harmonic instead. Harmonic looks mostly as a sinus wave going back and forth. So by using that and then change damping to 0 and rest length to 1.3, then if I run the animation, you will see what happens. The motion is now slowly back and forth to the planet in a smooth movement. And it will do that for like infinity, since we have no damping here. If I now put in a noise amount, then I will disturb this harmonic feeling, this harmonic force. So I put in some noise amount, just to be a bit bad. I set it to 10, and then I start the animation again. Then you see that it doesn't look so harmonic anymore. Some of the stones are moving, while others are almost still. and the amount of noise will eventually kill all the harmonic force. Could be some exceptions, but now almost all particles have stopped working and the last stones give up here as well. So noise amount disturbs all the forces, so that could be good to have if you feel that you are getting a too repetitive force or that everything is following the same path. So like one good example is to disturb path when using curves and forces together. Okay, then we have fall off. I changed back to force, so it will be turbulence, and then it will be easier to show the fall off. Fall off works like this. If you don't have any fall off at all, the force continues for infinity. It lacks borders, and the turbulence here will be in like our complete scene. So even if the stones are moving away from the source of the force, they will still be equally affected all the time. However, by using the fall off, we will tell the force to be weaker and weaker by the distance from the force. So with some power, you will have less and less movement out here. However, the stones will continue anyway, even if we don't have any force left. It got pushed in the beginning and then started to move because of the force. When the force has ended for that little rock down here, it continues to move in the same speed that it had just before the force ended. And the reason for this is because we don't have any counterforce that pushes the stones back. So we only have one force starting everything, and then it's like space. Nothing is stopping the stones. So they will just continue move forever. Okay, let's continue this. Using a value of power makes the fall off to work immediately. The force will be weaker by the distance, so it would be a bit weaker here and even more here until you have no force at all. If you check use minimum and set the value in min distance, then the force will work at full strength up to this line here. After that line, the fall off will start and the force will be weaker and weaker. By using a max distance, checking use maximum and set the value in max distance, we will create an outer border. Inside that border, it works as before and gets weaker by distance, but if it should be some force left when reaching outer border, it will be removed totally, so no influence outside that line. As we put the parameters right now, it's like maximum force and with strength of 1 until it reaches 1.7 meters in my case. Then it will start to fall off depending on the power. I put here until we reach max distance, and then we will have no force left. So when I run the animation, it starts to full force here, strength of 1, all the way out to the inner border. Now when it reaches the border, it will continue the movement, but with less influence from the force, so it's more like straight lines outside the border. We have lost all the force, and the particles just continues in the direction and speed they had without any new changes from the force. They just continue here, as you can see. So that is how it works. Okay? I will now go through how I did the introduction clip we had in the start. So first we change the type of force. It should be changed to a vortex. When I run the animation later here, you can see that the rocks are now rotating. In fall off, I set power to 0. I uncheck use minimum and use maximum, and then you can see the rocks are rotating much as it did in the clip. The only problem we have is that it's expanding forever. In most cases, when we work with forces, we have more than one force. In this case, we need a force that pushes everything back again. So to add another, press Shift A and force field and use force. By using force, we can push everything back to the planet again, and thus avoiding the expansion. So if I run the animation, you can see how the new force works. Right now it's expanding even faster, and that is because force now pushes the wrong way. So that is because we have a positive strength of the force here. So I change the strength to a negative value and run the animation again. And you can see now how everything is moving towards the center and then stops. So by changing the sign of the value, we change the direction of the force. Now let's fine tune it so it will be the same as I had in my clip. So we start with the rotation. Select field in the tree and check that you use vortex. And after that, check the strength and remember the value. Go to field 001 and put in the same value, but with a negative reversed value. So since I had 2, we put in -2 in the strength for field 001. So now we have like equally strong in opposite directions. To make all more static, we can also use flow. So if I set flow to 0 and run the animation, you can see that the pattern of particles are very individual, and every particle is selecting like their own path. And to make that like more homogeneous path for all, so they are like following the force more closely, we just increase the flow a bit. I set it to 1 and then I run the animation again, and then you can see that everything will be like flattened out, so it follows the vortex better. And after a while it stabilizes and gets a stable rotation. When we increase the flow, we transform the force to airflow, and by that weaken the flow. With some tweaks we can get what we want. So let's start by decreasing the flow a bit and activate use minimum on the vortex. Then we can use full force all the way to the inner border. So if I change it like this, then we have a force also a bit outside the planet. Now the full strength of the force will be used all the way out here. If I run the animation, you can see that it will expand and use this force as 100% until it reaches that border. Then the force transforms to flow, the rock stabilizes, and we get a really great looking thing like this. And it can go on like almost forever. However, since we have not used maximum, it could be a small amount of vortex that slowly pushes the rocks outwards. So we have like no safety barrier on the outer border. So it can be that we don't get like fixed position of the rocks, counted from the distance of the planet. But to prevent it from happening, I can just like add an outer border or on the sphere as well. And this I check the use maximum, and then I can control where I should cut off the vortex force like completely. And that means that we then only have the active force outside that area, and that will pull back all the rocks if they are still expanding. So we run the animation, you can see everything is shaping up fine, the rocks are expanding, loses some force, and finally stabilize between the borders. There are some like wobbling of the rocks, but it's because we have the borders very close to each other. The outer cuts the force that still we have a lot of to 0. Then the force drags back to the planet in high speed. So it could be good to increase the max distance a bit to get more smooth movement around this planet like I did now. So if I change it to around 4 and then run the animation, you can see now that it's much smoother because the vortex already have lost most of the power when reaching the outer borders. So it will not react so much when it comes to the outer border here. So by putting it like this, you can then be safe that every rock will stay inside this area. So it will never expand more because the force that attracts the particles to the planet doesn't have any borders. So when no vortex force remains, they will go towards the planet again according to the force. So that is how it works. I said in the beginning, this is more like an introduction. So I will not go through more how the forces work in this session, but you have seen the vortex and force work together. The main thing you learned in this chapter was about fall-off and strength, and that you often have 2 or 3 different forces working together to get the result that you want. As you could see here with the planets and the rock. Last thing now for this session is that in most cases you have an initial starting period of the animation. So you can see the rocks going from the inside out here right now. And to avoid that, you can go back to the frame 1 here. So we select the emitter and then go to particle properties. And in the frame start, you can then add a negative number. So let's say we use -500. And we would use that on frame start, but we also put that on the end. Then you already have done all the initial phase, so when you start the animation, everything is fine from the beginning. So by doing this change, you can do all the preparations and simulations on every particle until everything is stable, which could be 100 or 500 frames forward, and then the real animation starts. So by using a negative value, you can hide the simulation of the particles before the real animation starts. Okay, so that was a little bit about the forces. For the next sessions, I will go through all the forces one by one, so you know how they work, or you know how to work with them. So I see you in the next session, and I just say bye for now.